Hello friends. So in the previous video, we have concluded our discussion on independent voltage source. So today we are going to start with the independent current source. So let us start by understanding what is the definition of an independent current source. So the definition of independent current source is very simple. It is a type of an element, the current in which the current through the element is independent of the voltage across it. So it's very simple. That is, the current through the element is independent of the voltage across it. What was the definition of an independent voltage source? That is, the voltage of the element is independent of the current which is flowing through it. Similarly, in a current source, the current of the element is independent of the voltage across it. So what does that mean? So just like the voltage source, let us try to understand this. So for example, here you are having your current source. This is your current source. I'm not going to draw the complete symbol, that we'll see in the representation part. For example, this is the element and it has a current I1 which is flowing through it. And the voltage across that element, let us call it as V. Now, whatever be this voltage value across this element, the current value will be always constant. That is the meaning of an independent current source. Again, this definition is correct for an ideal independent current source. In practical current source, there is a small deviation. But in this course, at this level, we have to assume that all the current sources that we are going to deal are ideal current sources. So the idea here is that whatever be the voltage, okay, so let's just draw a table here. So if the voltage is V1, V2 or V3, where V1, V2 and V3 are different values, the current will be always I1. The current value will be always I1. That is the meaning of an independent current source. Now, as such, there are no direct examples of current source. For example, in a voltage source, you saw that a battery is a good example of a voltage source. Your wall outlet is a good example of a voltage source. But as such, in independent current source, I cannot tell you a direct example from real life. Usually, these are specific circuits built. Specific circuits are built as current sources. And these types of circuits are extensively used in semiconductor circuit design. Okay, they are extensively used in semiconductor circuit design. These types of current sources. Now, if you want to see an example, a simple example is an op-amp based. This is an op-amp based current source. Op-amp based current source. However, we will not be understanding the working of this circuit. This is just to give you the idea how a current source might look like that. If you take an advanced course in analog electronics, you might be even actually able to build these types of circuits. So with this, let us now move on to the graph in which we will be plotting the graph of current and voltage for an independent current source. So here you are having the voltage axis and here you are having the current axis. So what will be the shape of the graph? It will be very simple. So whatever is the voltage, V1, V2 or V3, the current is always going to be the same. So I'll mark V1 here, I'll mark V2 here, I'll mark V3 here, I'll mark V4 here. So whatever be the current value, whatever be the voltage value across the element, the current value is always going to be the same. So for our element, the current value is I1. So whatever be this value, the current is always going to be I1. So for V2 also current is going to be I1. For V3 also current is going to be I1. And for V4 also current is going to be I1. So the graph will look something like this. Okay. So this is a constant current. Constant current for an independent current source. So with this, I hope you have understood the definition and also the graph of the independent current source. Next, let us move to the representation. So we saw the voltage source representation. Now we have to see current source representation. So usually current source is represented something like this. This is the current source representation, which has a current value and a direction here. So this direction is actually showing the current direction, shows the direction of current. Okay, so this can be say 2 amperes, 3 amperes. It can also be minus 1 ampere, minus 3 ampere, anything like this. So for example, this is in the upward direction. You can have another current source which looks like this and it can have a downward direction. So this can have 1 ampere, 2 ampere or minus 1 ampere, minus 2 ampere. It doesn't matter. So this is the representation of a current source. So I hope you understood the definition of current source and also the graph associated with the current source and also representation of the current source.